we are graphing angles in the coordinate plane, it's extremely important that we understand a quadrant 1, quadrant 2, quadrant 3, quadrant 4, x-axis, y-axis, and everything that's positive goes counterclockwise, everything that is negative is going to go clockwise. All right? Any questions about the coordinate plane? All right, let's get a definition in. Standard position. An angle is considered to be in standard position if it's, does anybody know the definition here? What is standard position? Standard position is an angle drawn in the coordinate plane whose vertex is at the origin and whose initial side is the positive x-axis. It's an angle drawn in the coordinate plane where its initial side is the positive x-axis and the vertex is the origin. Now, we could draw angles anywhere. You could draw an angle that had a vertex of 4, 3. All right? You could draw an angle anywhere in the coordinate plane, but standard position is going to place the angle at the vertex at the origin with the initial side on the positive x-axis. And if we can transpose things to that location, then we can work with things a lot easier. We're not going to have to do that much, but so standard position, if I erase that too quickly, we can go back to it in a second, has its initial side on the positive x-axis. So the angle, the starting point of the angle is called the initial side. The vertex is at the origin. And then the angle is going to sweep out. It's always going to have a directional arrow. The directional arrow is an important part of the scenario. And this is called the terminal side. So every angle has a vertex. It has an initial side. And it has a terminal side. That's kind of the anatomy of our angles. And this thing right here we call our directional arrow. That directional arrow tells us which direction that the angle is rotating. So all of those are going to be necessary parts of drawing angles. You've got to have the initial side shown, bless you. We've got to have the terminal side, and we have to have our directional side. Okay? Chicken scratch, I know. Directional arrow, initial side, vertex, terminal side. All right? Now, the location of the terminal side identifies where the angle is. So this particular sketch is a second quadrant angle. All right? It's always important to know which quadrant the terminal side of the angle is going to end up in. So quadrant 1, this is a second quadrant angle that I've sketched here because the terminal side is in the second quadrant. And that's going to be extremely important when we start covering our lesson on Monday, which is going to be our first somewhat challenging lesson of the year. So we have the standard position of our angle as an angle is drawn in the coordinate plane whose vertex is the origin and initial side is the positive x-axis. Wherever the terminal side is the quadrant that the angle is actually a part of. All right? Now, sketching in standard position. Let's use that, what we just defined, to sketch 120 degrees in standard position. Now this next test, the test number 1, is going to have you have to sketch angles. You probably will have to sketch this angle on the first test. This is easy stuff. This is the stuff that I was telling you need to be perfect at. All right? So if we're sketching 120 degrees in standard position, we want to start with drawing a little x and y axis. You don't have to label it or anything. We're going to just do that. The initial side, because it's in standard position, is going to be there. And then we're going to go 120 degrees in which direction? Counterclockwise, right? So we're going to go 90 and then just a little bit more. 30 more is going to take us right there. The directional arrow is going to be there, and we can label it like that as 120 degrees. So that's what the angle is going to look at. Now, what quadrant is 120 degrees in? It's in quadrant 2. Now, I don't want you to do a whole lot of thinking about what I'm about to tell you, but on Monday it's going to be very important that we be able to identify what this angle is. What's the value of that angle? 60 degrees. Okay? You don't even need to write that today because I didn't assign any meaning to it yet. I just want you to kind of start thinking about that. All right? What about 600 degrees? Can you go all the way to 600 degrees? Sure. What do? We go all the way around, and then we go around some more. Right? So that's the purpose of the directional arrow. It shows us what we're doing. So our initial side, again, is going to be the positive x-axis. I don't want to use green. Positive x-axis. My directional arrow shows the direction that the angle is going to go. So if I go all the way around, it's just going to be 360, right? And then I'm going to go 90 more would be 450. 90 more would be 540. And then I need to go 60 more to get to 600 degrees. All right, need a directional arrow there. Boom, boom. That's why the directional arrow is important. Right. I need to know how many times I went around. So you should be able to look at an angle like this, and if you've got the arrows, you can retrace it, right? You could retrace this and say, okay, that's 360, 450, 540, plus some, a little bit more there would be 600 degrees. And this angle right here, the angle we're going to be interested on Monday, if this angle would be, again, would be 60 degrees. Okay? Any questions? All right. Now, we can also think of angles being sketched in a negative direction. Negative 240 degrees is, instead of going in a counterclockwise direction, negative angles go in a clockwise direction. So to sketch negative 240 degrees, we're still going to have our initial side on the positive x-axis. And instead of going counterclockwise, negative angles go in a clockwise direction. So let's see, we'll start here and go, let's see, that would be 90. 180 plus 60 more is going to end up somewhere in the second quadrant. That's negative 240 degrees. Easy enough? Now, what's the 3 parts that every angle sketch has to have? It has to have, the vertex. That's one of, we count the vertex, that would be 4 parts. This is the initial side. All right, we have to have our terminal side, and we have to have our directional arrow. Okay, the directional arrow is a requirement. So it has to have the initial side, it has to have the terminal side, it has to have our directional arrow involved. Okay? All right, practice these 4 angles. What quadrant is 48 degrees in? It's a first quadrant angle. Now, since we're on the subject, let's talk about the first quadrant angles. Which angles are in the first quadrant?
0 and 90.
What do we call those angles?
Right angle.
90's right. What's between 0 and 90? Acute angles. So the first quadrant contains all acute angles. Okay. What about 90 to 180? That's the second quadrant, right? What kind of angles are those? Obtuse. So our acute angles are all going to be first quadrant angle. Our obtuse angles are all second quadrant angles. 180 to 270 is the third quadrant, and 270 to 360 is the fourth quadrant. All right, so it's kind of good to know that. What quadrant is 355 in? Fourth quadrant. Negative 230 degrees is a second quadrant angle, right? All right, I didn't see any issues that we needed to have a look at. Now, the other thing that we're going to do today, just as basic skill stuff, is convert radians to degrees. Now, we're going to use radians for the most part. We'll use degrees some, but by the middle to the end of the course, when we talk about trig functions, we're going to be talking about in radians. We're just going to be speaking radians. All right. And if I were to compare this to anything, radians to degrees is like the English system or the metric system versus the English system. Pounds and pounds to this, pounds to kilograms. All right, conversions. So that we're going to be doing unit conversions, and to do unit conversions, we're going to need a conversion factor. Just like 4 quarts is equal to a gallon, 180 degrees is equal to pi radians. Now, this is literally the number pi, the irrational number pi, 3.14159, the irrational number. Pi radians is 180 degrees. That's where we're going to get our 2 unit conversion factors from. All right? And then here's what I mean by that. We can take this pi radians equals 180 degrees. You could divide both sides by pi radians. And one of our unit multipliers is 180 over pi. (180 over pi) has a value of 1, so we can use this as a unit multiplier to do unit conversions. All right, we could do the same thing. We could take pi radians equals 180 degrees and divide both sides by 180 degrees. And then we get our other unit conversion multiplier. Pi over 180 equals 1 also. So there's our other unit multiplier. We'll use one of these unit multipliers to do our conversions when we're converting from degrees to radians or radians to degrees. Okay? But I want you to think of pi as what? Pi is 180 degrees. If I were to look at the sketch of that, that would be right there, pi radians. 180 degrees. Which means 90 degrees. Well, we'll get there in a minute. Okay? So our 2 unit multipliers that we're going to use to do our unit conversions are 180 over pi and pi over 180. So if we're converting this degrees to radians, 120 degrees, we're converting it to radians, I've got to use one of those unit multipliers. Which one am I going to use? Pi over 180. Why do we use pi over 180? To cancel out the degrees. That's exactly right. Whatever you want to cancel needs to go on the bottom. Okay? So the degrees will cancel, and I'm left with 120 pi over 180, which I'm going to simplify. Both of those are divisible by 60. Right? 60 goes into 120 2 times. 60 goes into 180 3 times. So 120 degrees is 2 pi over 3. Okay? Now, I want to give you another way to think about this, because this is the way you're going to have to think about it as you move on through the course. You're going to have to learn to think in radians. What's pi? 180. What's 180 divided by 3? That's 60. And 2 60s is 120. All right, so that's kind of how I want you to learn to think of pi. Pi is 180 degrees, so we're going to have some things that work out for us. 235 degrees, if I want to convert that again to radians, I need the degrees to go away, so the degree Unit needs to be on the bottom, so I'm going to multiply by pi over 180 degrees. Right? The degrees will cancel. And I'm left with 235 pi over 180. Both of those are divisible by 5. Now let me take a little tangent here. Do y'all know how to use your calculators to simplify fractions? Do you? Okay. The graphing calculators, everybody know how to use the graphing calculator to simplify fractions. Do you or don't you? Here's how it works. I'm surprised if you do. 235 divided by 180 is what you do. You hit enter, and that's going to give you a decimal, right? And then you're going to press the math key, and the first option under the math key changes it to a fraction, changes it back to a fraction. So if you just press math and hit enter and enter again, it'll turn this back into a fraction, and it'll tell you that that's 47 over 36. So this is 47 pi over 36. All right. If you learn how to do that, difficult simplifications, are a lot quicker than kind of having to think about what it might be. You can take that off the radar. We're not going to really talk a whole lot about, bless you, simplifying fractions in college trig. All right. If you can't do it manually, quickly, use your calculators. All right. So let's think about these. Put your pencils down for a second, and let's think about these without actually doing or using a unit multiplier. What would 30 degrees be converted to radians? It's 1/6 pi over 6, right? Because what's pi? 180. 30 is 180 divided by 6. So 30 degrees is pi over 6. Right? What about 45 degrees? Pi over 4, right? 45 is half of 90, and we got 4 of those, right? 45, 90, 135, 1 is fourth. So this is 1/4 of pi, or pi over 4. 60 degrees, pi divided by 3, right? It's 180 divided by 3. 90 degrees, pi over 2. All right, 360 is pi times 2, so it's 2 pi. 270, think about it this way. 270 is 3 of these, isn't it? 270 is 3 90s, so that's 3 pi over 2. Okay, now these angles are the special angles, and we're going to use them often. All right, what's the significance of these angles as it relates to what we talked about yesterday? Is there anything over here on the board, any of these triangle facts that apply to these angles specifically? $30, 60, 90, 45. Right? Those are, 30, 60, 90, and 45 are all angles of our special right triangle. So that special right triangle relationship is going to be extremely important to what we're going to do in this class. Okay? What's the significance of 90, 360, 270, and 180? 180 is not up here, but 180 is the only angle that's left out of the picture, because we know that's pi, right? 180 is pi radians. What's the significance of those 4 things? Where's 90 degrees? Crickets. Crickets. Where's 90 degrees? This is it right here, isn't it? This 90 degrees. What's this? That's 180. All right. This would be 270. And this is 360 degrees, which is the same as 0 degrees. So what's the significance of 90, 180, 270, and 360? Those four angles make up the what? The x-axis and the y-axis, all right? 0, 90, 180, 270, and 360 are what we call the quadrantal angles. Quadrantal angles, all right? Quadrantal, quadrant AL, quadrantal angles are the angles that actually make up the four quadrants. Okay, so those are the special angles as well. So all the special angles in trig are 30, 45, 60, 90, and then 0, 180, 270, and 360. Okay, so that's kind of very, very important. And that's the significance of those. But it's also going to help us think. All right, let's convert radians to degrees. Now, I want you to think of this in terms of the pieces. All right? 5 pi over 4 is 5 pi's over 4. And what did we just say pi over 4 was? 45, right? 5 times 45 is 225 degrees. Now, you could actually go through the unit conversion process, which may be a good idea for you to do initially. We need 180 over pi because I need the pi's to cancel out. Right? The pi's cancel out. 4 goes into 180 45 times, and 5 times 45 gives us 225. Okay? If we have to actually use the unit multiplier, that's okay. And in some instances, you won't have any choice. You'll have to do it that way because we won't be dealing with pi over 3, pi over 6, pi over 4, or pi over 2. Okay? All right, what about this one? 7 pi's over 3. What's pi over 3? That's 180 divided by 3, which is 60, and 60 times 7 is 420 degrees. All right, 420 degrees. Now, if you had to actually do 180 over pi to see that, that's fine. The pi's cancel. Again, 3 goes into 180, 60 times. 7 times 60 is 420 degrees. All right. What about sketching these radians? Sketch. How would you sketch 7 pi over 6? Let's think about what 7 pi's over 6 is. What is pi over 6 again? 30, right? Pi over 6 is 30, so 7 of those is 210 degrees. So our initial side is going to be there. We're going to go 180 and 30 more. And 210 degrees is what we're going to be working with. There's 7 pi over 6. Can you dig it? It's not tough, right? It involves a little thinking involved, but as you think about this every day for the next semester, you get good at it. Hopefully quickly. All right. Negative 7 pi over 4. Now, which direction is this angle going to travel? Clockwise, right? We know it's going clockwise, so our initial side's there. We're going to take off this direction. All right. What's pi over 4? What did we say pi over 4 was? 45 degrees, right? So y'all watch how I do this. How many of those 45 degrees do we need? 7 of them. So there's 1 45 degrees. 2 45 degrees, 3 45 degrees, 4 45 degrees, 5 pi over 4, 6 pi over 4, and then 1 more, 7 pi over 4, negative 7 pi over 4. All right, so all I did is go, count this thing out, 7 pi's over 4. Didn't even really think about what degree it was. I just know that pi over 4 is half of a quadrant. So I need 7/2 of a quadrant because each quadrant measures 90 degrees, which is pi over 2. All right, so we'll learn to think in radians as we go. Now, so how would you sketch this angle? What is pi over 3? 60. That's first quadrant, right? 5 pi's over 6. Pi over 6 is 30. 5 of those is 150. Right? 7 pi over 4. We just did 7 pi over 4 in a negative direction. Let's do 7 pi over 4 in a positive direction. Pi over 4 is half of a quadrant. It's 45 degrees, right? So 45, 45, 45, 45, 45, 45, 45. Was that 7 of them? 1, 2, 3, 4, 5, 6, 7 pi's over 4. So that's what that angle would look like. It's a fourth quadrant angle. All right, any questions? Homework. Section 2.1, 7 through 18, and 21 through 26.